Alright, yeah.
Number 8, torque equals force perpendicular times radius. I've said that how many times today? I want you to state, that will help you answer number 8. It'll state 3 possible units for torque. Just come up with one that we use all the time would be good. But then you got to think of 2 more that are possible. So this is number 8, stating 3 different possibilities for units for torque. Well, the first one we talk about all the time, and looking at force and radius, I know force comes in newtons and radius comes in meters. So Newton meters is the one I'd expect you to put down. I can't mark it wrong if you don't, if you got another one. So what about in America? We don't do force with newtons, we do force with pounds, and we do length with feet. So we have, I put pound foot, we usually call it foot pounds, but the way my formula was stated, it ended up on that side. So foot pounds, pound foots, pound feet. And then I thought, well, I like the English side, American side, so I thought, well, pounds, another unit for weight is ounces, and another unit for length is inches. So I came out with ounce inches. So those are 3 typicals, not typicals, but 3 possibles. Does anyone have another unit? You cannot have kilograms in there, because kilograms is mass. So if you have kilograms, that's not right. What else can't you have?
What about centimeters?
Centimeters is fine.
Millimeters?
Millimeters is fine.
Kilometers?
Pardon?
Kilometers?
Yep, kilometers is fine.
What about slugs?
Slugs are mass, sorry, no slugs. We are looking for units of force, and slugs are mass. So it has to be a force unit, and it has to be a length unit. Molly?
Do you know what you said a liter? Because that
Hmm?
is a weight, a liter.
A liter is volume, so that's not involved, sorry. All right, so you'll have to come up with some units or recognize units tomorrow, or Wednesday, we don't meet tomorrow. All right, Wednesday is a short day, but I don't have anything I have to test. We'll find time for you if you need it.
You seem to always test on Wednesdays.
I know it's a pain, but we're so far behind, we need to keep going. So I'll find you some extra time.
We're far behind, just look at our calculus
Yeah,
class.
for real. Yeah, we're really far behind.
Really? How do you
We're
know?
on chapter 2 in the syllabus, we're supposed to be on chapter 4.
Oh dear.
Oh dear, it's right.
We're just finishing chapter 2.
All right, we'll just meet in the summer. All right, fine.
Summer's no!
Tension
Last
1 and
week.
tension 2. Tension 1 and tension 2, we're trying, I'm hanging, what do you call it, wind chime. The wind chime is 2.5 kilograms. Can you hear the wind chime? 2.5 kilograms, and tension 1 is 25 degrees, not tension 1, the angle of one wire is 25 degrees and the other is 45 degrees. The tension in the 25 degree one is called tension 1, the other one tension 2. Find both of them. These are the longest problems on the test, so there are 2 of them. I probably will cut off one just because it is a Wednesday. So, but you will have to do one of those. So,
And that's the first thing we learn in this chapter.
yep, this is the first thing we did in this mod. All right, first thing I want to do is start a diagram of all the forces involved, but this isn't a force, so I always start there. So if you are working along with me, you can do that. Just change mass to weight. And the one thing you should do when you leave my class is know how to change mass to weight. So we're going to take the 2.5 and multiply it by 9.8. And we recognize that the weight is downward. So when I took 2.5 times 9.8, I got negative 24.5. Check me, someone.
Yeah,
All right, now we go on. We're going to draw a force diagram with that information. I don't need that right now. Maybe I'll bring it down a little so you can see that number. I'm going to do a force diagram where I put in all the horizontals and the verticals. So, And I also changed the angle. Remember, this is a 25-degree angle right here. And this one is disguised as a 45-degree angle, but we know it's not. It's really wherever when you start here and you go all the way over to there. So we have to figure out what the 45-degree angle really is. And I did that over here by subtracting 45 from 180. So it's really a 135. So make sure you include the 135 when you do that. So notice I use sine to do the verticals, and I use cosine to do the horizontals. Remember how we did that? We were good at them at one time, but then we put it away, and it's coming out to play today. Yeah, maybe, we'll see. Hopefully not. I started down a chart here. I have horizontals on one side and verticals on the other. Let's go down the horizontal side first. All right, horizontally, the sum of the forces equals MA. And I'm going to recognize how many, Alex, you were good at counting them, how many horizontals in this case? 2. So I saw T2 cosine 135 and I saw T1 cosine 25. And those are the only 2 that I could find. And Alex agreed, and I set it equal to 0 because the MA, it's still, the picture, there's no wind, it's still, so can't hear it. I plugged those in the calculator, cosine of 135 and cosine of 25. And I got these numbers. Please check them for me. Make sure I wasn't in radians and make sure you're not. You can't go a whole lot further than that. So you need to solve for either T1 or T2. I usually move the negative one over and solve for the one that's left. That's just my pattern. So I moved the negative one over and I solved for T1. If you solve for T2, that's okay. We'll end up at the same spot. So I got, at the end of the horizontal side, I got T1 is 0.780 T2. Anyone do that and check my numbers? Are they okay?
We went ahead. What did I do?
No, that's what I got for that. Okay, all right.
So stressed.
I didn't solve for that. I solved for T2.
Okay. That's
Oh,
all
no,
right.
yeah, that's what
I did
thought.
solve for that, and I did not get that.
That's not the answer, Morgan. That's just.
No, I know.
But for that part,
Oh, wait, no,
I
I
did
didn't.
not.
What did I do?
Did you go T2 equals something T1?
Wait, that's the
I
whole
got
problem?
T1 equals.
No, you just do the horizontal, like you're solving.
Okay, so we're
You
doing
plug those
the,
in, and then you
vertical
do,
next.
yeah, and then you plug that back in, substitution.
I did 0.91 instead of 0.906, but that's just gonna make that much difference.
Yeah, I should have.
I keep getting 1.3.
Well, you probably just did it the other way. You probably have T2 equals something T1.
Oh, yeah, that's what I
That's
did.
fine. That's
Oh.
fine.
Is it supposed to be like a different, is that like the, is it
Yeah,
okay
you
if
can
I
go,
do
you can
it?
solve, right here, you have a choice. You can solve for T1
Okay.
or T2.
Oh, we still got it.
I just usually do this way. You'll come, we'll meet, our minds will meet in a bit.
Can we possibly keep both of those up?
Yeah.
Because I need to.
All right, so now we're going to come down the vertical side. Sum of the forces MA. How many vertical ones, Alex? The force counter. 3. So I had T2 sine 135, and I'm adding T1 sine of 25 minus, remember the weight was downward, 24.5 equals 0. So then I have to go on another transparency. That's not the answer, obviously.
I
So,
changed cosine and sine.
oh, you did?
Yeah, instead of doing 2 sines, I did sine and then cosine.
Okay. Yeah, the horizontals are cosine, the verticals.
It's okay, I just changed one.
Let's see if I can put this up at the same time. Doesn't look like
I
it.
think I have that.
Alright. Alright, so let me just switch. Here is the last line from the first transparency. And